Hi, I'm Dr. Padilla. Here we talk about all things data visualization, and today we are talking about scales in Vega-Lite. Scales can be pretty easy in terms of manipulating and modifying them, but successfully conveying your data with the right scales can be a little bit more challenging. So let's jump on in. Here we're working with this DC Marvel dataset that I got from this 558 story, which is excellent. You should take a look at it. What it depicts is different Marvel and DC characters over time, and it denotes certain data that was pulled from Wikipedia information, including gender, the year that they were introduced, hair color, if they are dead or alive, and if they are considered positive or negative characters, which is really cool. So first, what you want to do is import Vega-Lite and also import this data set. I have it here on my GitHub account, and I'll include this code in the description. Now let's talk about the basics of scales. Scales in Vega-Lite simply translate the range of your data to some visual range or attribute. Vega-Lite is excellent in that it has very good defaults, which usually get you most of the way there. There might be situations that you might want to customize or make different choices than Vega-Lite has in terms of their scales. There's two key types of scales. One is quantitative, so where you have some type of quantitative value. The other is categorical, which is what we'll start with. Categorical is when you have defined, finite, discrete categories or bins that your data is organized into. You might be looking at data across different countries. Those countries are discrete, so you might want to visualize those independently, and you would be using a categorical scale for that. You can use both nominal and ordinal data. Nominal is non-ordered categories, and ordinal has some type of sensible ordering. Some of the key features of categorical scales include a discrete domain where your data has truly independent categories or levels to it, like apples, bananas, and cherries, and it's going to have a discrete range, which is what you're using to map onto the data. Like color, for example, you might map apple to red, banana to yellow, and cherry to pink. Maybe you pick a better one for that. And then this mapping will be the thing that connects the two together. Okay, so let's start with a very simple chart. We're going to start with VL mark. We'll use a circle, and then we're going to add our data to that, and we've already loaded it up, and it's that comics data. And then as we do, we're going to encode, and we're going to add for our encodings an x-axis, and that field is going to be for a column in our data set called appearances, and we'll add ourselves a y-axis, and that field is going to be nominal, and this is going to be sex, which we will rename to gender. This data was collected in 2014, so it has all the implications of what people thought about data in 2014. That would be enough to get going. We can render that. And that gives us a very simple chart here where we have the different genders here on the Y and the number of appearances that they had in these DC and Marvel comics. Now, just to add a little bit more intricacy to it, I'm going to add a color, and I'm going to make that one this align value, which will specify if the character is good, bad, or neutral. And I'm going to name that character type just so it's easier to figure out. And add a comma back in there. I didn't add the quotes to that. Okay, great. So now what we have going on is we have a data set that shows the different genders and if they were registered as bad characters, good characters, neutral, or reformed criminals, which is pretty interesting. This is a very fascinating data set to unpack. One of the things we notice is that the male characters, there's just a larger proportion of them generally. We're seeing lots of red, even though it is a bit hard to decode with what we have so far, but it appears that they're more good characters. Same for female, and it's kind of hard to unpack these. Now we'll use scales throughout the next few tutorials to try to reveal more of the nature of this data. But one thing you might be noticing right off the bat is that there appears to be some missing data here, and there certainly is in this data set. So you might remember from a previous transform video that one approach to dealing with missing data is to transform it, and the transform we're looking for in this case is filter. So what I'm going to do is I'm going to filter out the datum for a line, and it's in capital, and I'm going to make it not equal to a space. Okay. And this is in part because I've already explored this data set and I know that the missing data was coded as spaces. What you'll have to do for your data set is determine how the missing data was encoded. Sometimes it's coded with 999s or NAs or other things. In this case, it just happens to be a space. So then we'll also do that for the sex value. We run that and it's basically just filtering out the missing values. One of the things when we first look at data sets like this that I might recommend to you is to consider sorting the categorical values. If there's no inherent ordering that is interesting to you, one thing you can do is just sort them based on the quantitative values here on the x-axis. One of the reasons you would want to do this is it's actually faster and easier for people to identify the trends if they're sorted. I'll show you how to do that. So here on our y value, we would add a sort. We would sort and we'll specify the field to sort by. In our case, we want to sort by this appearances, how many appearances these different characters had. And then the operation, because the appearances were just for the individual character, we actually want the sum of each of these groups' appearances. The operation we'll use is sum on this. And then the order we'll do as descending. And what we have here is the highest number of appearances. It's sorted our y-axes that are categorical based on the highest number, which is good. And then we can clearly see that males are first, then females, agender characters, gender fluid, genderless, and then transgender characters here at the bottom, which is very interesting. And of course, you can always do this as ascending as well. And it just reverses the order. There is a natural mapping where we feel that more is up. This is based on cognitive linguistics. They basically find that we associate higher values with more things. So the most natural mapping to do this in is to have the version that has the most values on top and in descending order from there. Now, the next thing you might want to do is if you actually do have an interesting ordering that you would like them to be, the next thing I'm going to show you is if there is sincerely an order that you would like to manually specify, there's an easy way to do that. I don't see any real natural order in between these gender values, so I'm actually going to switch the axes around a little bit. I'm going to change align and sex, and I'm going to make it so that the align is on the Y and sex is what we're coloring. Okay, I just flipped around the axes. So we will take away this sort. So now we have the character type on the y-axis and gender over here in color. And I do think that there is a sensible ordering for the character type. I'd like it to go from good characters to neutral characters to reformed criminals and then to bad characters. And that is pretty simple to do. So we would go ahead and add the sort to our new y value here. And it's really just an ordered list. So we have good characters, neutral, reformed, and bad characters. And then it will rearrange them as such. That's pretty simple to do, but you'll find you're making these moves a great deal when you're visualizing your own data, where you might sort the data or specify the ordering of the categorical axes. I hope the simple introduction into categorical scales was useful. As you can see, it's pretty easy to customize the organization of categorical scales. It will get much more complicated with quantitative scales, which is what we're going to cover in the next video. So stay tuned for that.